Hi, my name is David Whale. I'm a software engineer and I've been writing software since I was about 11 actually. And I just wanted to say a few things about writing software and why I chose software. So originally when I was about 10, I was really deeply into electronics and building electronic circuits. And I used to build little things like this. This is actually something I built when I was quite young. It had um, 4 little logic chips on it and some transistors and some LEDs, and it was based in electronic dice. And you press the button and it would spin through some random patterns, and then it would stop on a particular pattern. And I soldered it all together myself on a bit of board, and this is probably one of the early projects that I built. One of the problems with making electronic projects, though, is you have to power them, and so this is what this wire here is for. You plug it into a battery, and you have to spend money buying components. And there was a computer electronics magazine I used to buy in WH Smith's. I used to save up for it, and I didn't used to buy every single one because I didn't have a lot of money when I was a child. But there was some projects in there that I wanted to build, and then I'd save for a few months to buy the components, and I then sold the components onto a board. I'd often cycle all the way to a shop in Ware called Buypack, where I could buy the components and buy the boards and everything. Didn't really have Maplins in those days, just about, I think, just about starting Maplins, but not in the high street store. So I had to cycle a few miles to get the components. I used to go there on a Saturday and used to spend the whole day in the shop deciding what to buy. I'd go and sit in the churchyard and eat my lunch, and then I'd go back and buy all the bits and cycle home, and then I'd spend the next few weeks building up projects. So one of the problems, of course, when you're 11-year-old is that it's don't get a lot of pocket money. You have to keep saving up for things. And once you built it, okay, it's great to have a thing that you built, but then you have to save up for some more bits. And I decided I'd spend a lot of money on batteries. So one of the projects that I built when I was a child was a little power supply. This is just the remains of it basically, but it had a dial on it where you could set the voltage, a switch so you could change it between positive and negative, some terminals down here, and quite scarily it was powered from mains, and inside it had a little transformer and a circuit that I built. And then this was my first real understanding of reuse, the fact that I could build one thing once. Oh, here we go. Made on the 14th of April 1984. A little Dymo tape. A little stick on the back says danger, 250 volts, and a fuse on the top. So I really started to understand reuse, the fact that you could build something once and reuse it multiple times. And so the problem with electronics was it was quite hard for me to get reuse, and I needed to keep saving up money and spending things. And then in 1981, there was an advert for a computer called the Sinclair ZX81, and it was just about affordable with all my Christmas money and birthday money from aunts and uncles, mum and dad, brother, next door. You know, anyone that would give me money, buy me presents for Christmas. I said, "Don't buy me a present." I said, "I need the money this year." And my mum sent the check away, and it was many months before this ZX81 came through the post because Sinclair was quite delayed in the production. And then just in time for my birthday, so I missed my Christmas present, but just in time for my birthday, I got this kit of bits and I soldered it together and it worked. And I wrote my first little program on it, little Hello World program, displayed my name on the screen or something. And I was hooked. I thought, this is great. So I spent the money once. And now what I could do was, if I had an idea for something, I could just type in lines of computer code, and then I could run that, and I could save that computer code on to cassette tape and load it back in again. So I didn't have to spend any money ever again. That was the plan. That didn't quite work out like that, but and this is a tiny computer. It only had 1K of memory, not 1 terabyte, not 1 gigabyte, not 1 megabyte, not 1 kilobyte. Just literally 1 kilobyte. So that's 1024 bytes of memory for everything that you could do on it. So of course I saved up and got the 16K memory expansion for it. But and what was great about this was that although I was interested in electronics, I could plug my ZX81 in on a Sunday afternoon when all the shops were shut, and I could have an idea, and I could type something on the keyboard, and what would happen was that would burst into life and it would do something. So I could go straight from the idea through the creative process to something that worked. And I really liked the fact that you could have an idea on a Sunday afternoon and type in lines of code and it would do something. And that was just hooked as a sort of 12, 13-year-old. Then I was completely hooked on that and just kept going with computers. And I stayed in software development all my life, and I still thoroughly enjoy it. So I really liked the zero cost of software, the fact that if I wanted something, rather than having to save up and buy it, I could write it myself. If I wanted some snazzy way of drawing lines on the screen and the computer couldn't do it, then I could write a bit of code and do some maths and it would happen. And throughout my career, I've spent pretty much all my career working on the full life cycle of products. So from the original idea right through to the thing finally shipping and end up in boxes on shelves and things. And I've got a couple of products here that I've worked on over the time. Just briefly show you. I tend to work on embedded software, which is software inside other products. So when I finished at college, I went and got a job for a couple of years, and I used to design machines, help to design the software inside machines that basically automatically made video cassettes. And I worked for that company for a couple of years, and then I went to university and studied computer science, and there was an intern year. I decided to do the intern year, and I worked for a company that made these things. So this is a portable gas safety monitor. It's battery powered, and it measures toxic and flammable gases, and people wear it around the neck when they go down into sewers and other areas where there might be noxious gases. And it has a really useful feature called the canary bleep. So just like the canary in the cage down in the mines in the 1800s. This is done by a computer, so it measures the levels of gases, and it bleeps. And if the gases are too toxic for you, or you have been exposed for too long, then it sounds an alarm. And this particular one, I worked on the project when I was as an intern. I went back to work for the company when I graduated university. We made a whole load of these. We made a test rig for them and calibration jigs and all sorts of things, and we sold lots of them. And then eventually they were end of life, and many years later I went to a boot sale and I found this at the boot sale for £1. And I thought, this has got my software inside it. And I thought, well, this is amazing because this particular device has had a life, and it saved a life. It saved Mr. Webb's life. So Mr. Webb is, still healthy today because he used a product that has my software in it. And that's what I call full life cycle engineering. So it really is from cradle to grave. So it's from the initial idea. I was involved in the team that helped to design the product, and it went out onto market, and then I finally bought one when they were end of life. After I spent some time working there, I did some teaching for a while. I actually taught at Harlow College for a few years, taught computing, and I then went to a company that designed the technology that went inside electric vehicles. Before electric vehicles were really a thing, I did a lot of control software for them. And electric vehicles are now, pretty much everywhere you go, you see electric vehicle whizzing past. And then I worked for a company that designed the chipsets that went inside mobile phones. I have another prop to show you. So this was one of the mobile phones that had our chipset and our software in. This was actually one of the pre-production prototypes. This is the very first BlackBerry that had GSM mobile communications. So that's got some of my software in. What I would say actually is that it's okay saying yes, it's got some of my software in, it's got a tiny bit of my software in. It's actually, there were hundreds and hundreds of people involved in designing all the chips and all the software that went inside this. A mobile phone is a very complex product. And then in 2006 I set up my own business, and a few products that I did. So I worked on a wireless PR movement sensor. This again is the pre-production prototype. In fact, I've got something even before the pre-production prototype. I've got the very first prototype that I hand soldered together myself with two little microcontrollers, two little crystals, and the idea was one was a transmitter, one was a receiver. This wire simulated the aerial, so it would transmit a message across the wire to the other one. It would receive it, and basically press a button, it would turn the light on. Again, soldered that together myself. Quite a simple product, but it's been quite successful. This was the pre-production prototype. You can see inside, you can see some of the components. That particular chip there has got the software inside it, and it has a battery, and in the back is a little radio transmitter. And then basically when someone walks up to your door, it sends a radio message and either rings your doorbell or turns the porch light on. I've actually got one outside that turns my porch light on when someone stands out. Another product I worked on very briefly was I worked for, did a contract for a company that did these things. This is a in-home display, an energy meter, so the dial lights up different amounts based on how much electricity you're using. And I did a lot of work on the software inside that. So again, I work on software, but I've generally, across my career, I've worked on software that goes inside other products. And I think software is a really great industry. There's still tons and tons of things that are happening. Obviously, there's a lot of new work going on in machine learning and big data and big website systems and so on. There's still a huge amount of development. But my route was that I started with electronics, and then actually software was a much cheaper way of me being able to innovate when I was a kid, and it just hooked me, and I've just kept going ever since. Today I run a business. I've run a business since 2006, and I do small-scale consultancy, again embedded work for a lot of clients. And I also spent a couple of years volunteering, and I ended up working with the Microbit Foundation for 2 years as part of the BBC project and 2 years as part of the original Microbit Education Foundation, and did a lot of work training teachers and writing resources and going out into schools and using microbits. And you'll probably, if you've ever seen a microbit, some of the resources that you might have used at school or college, I've probably been involved in writing those. In fact, I think one of the most famous projects that you see people doing all the time with microbit is a step counter. The step counter was one of my very first projects that I did. And that's me really. So I'm still going. I've been in the industry since I was 11, and I'm still really, really excited about it. And the one thing I really, really like about software is the fact that you can, obviously you need a computer, but without too much expenditure, you can sit in front of the computer and you can have an idea on a Sunday afternoon when all the shops are shut, and you can make the idea come to life. And my particular branch has been making pieces of electronics come to life with software, and the equivalent Hello World program on a piece of electronics is flashing an LED. So if you start developing some software and you start developing it for an embedded platform, the first thing you should really do is try and flash an LED. That's your starting point. And if you can flash an LED, you can take over the world. That's what I say.